And the case study is about a process. So we've done one packaging. We're going to talk about how we apply the modeling in the process system. Our customer for this was a beverage customer, and they had an obsolescence project to replace a batching system. Their goal was to rip out the hardware and replace in kind a proprietary batching software at the same time. It was very high profile. There was a high focus on downtime. They also had an interest in standardizing on that software platform because they knew they had a lot of other obsolescence projects to replace in other facilities throughout the country. So they wanted to also try and standardize on that approach and make sure they had standardized training and support that as they rolled this out across the country, they could support it and have some efficiency in delivery. And they also wanted to try and improve the batch efficiencies in terms of times and sequences. So there was some piping changes done for this project, and they didn't know how, they expected through the design process to figure out how to do some things a little quicker on the batch. So with that, I'm going to let Philip take us through this case study and explain how we used our modeling tools to emulate this project and deliver some solid results. You ready?
Yep, thanks, Damien. So before we look at the actual emulation, I'll explain the components of our system and how they are all connected. So there are three primary components to every emulation. We have the model, which acts as the real-world I/O. We have the PLC, and we also have the software on servers. So the software servers will usually, at a minimum, have the HMI software. For this project, it was FactoryTalk View. And if there are additional software components for the project, these can and should be tested with the emulation. In our case, our batch server is part of the emulation as well. So the PLC is running the actual code that you'll be running in the field. And this is what makes emulation so valuable, the fact that you're running the exact code you'll be running, and you get to see how that code reacts ahead of time. The blue arrows here represent the logical communications between the components. Just like in the real world, the servers and the PLCs talk to each other, exchanging information needed to display the system status for the HMI and also for control. However, for the I/O devices in our emulation, instead of the PLCs reading I/O cards from a local rack or reading it from a remote rack, the model reads the outputs from the PLCs. It then interprets them and generates the appropriate inputs and sends that back to the PLC. Note that there's no communication between the HMI or the batch server in the model, despite the fact that they are all connected via Ethernet. The PLC serves as the window to the real world, just like it would if we were in the field. So with that, we'll go and take a look at our emulation in action. So what you're about to see is an S88 implementation using FactoryTalk Batch and FactoryTalk View SE. As a reminder, we can use any software that you choose, Siemens, InTouch, they can all work as part of an emulation. However, for this particular project, FactoryTalk was the chosen implementation. So we're going to run a batch where we will utilize this tank 20. And what you're going to see is we're going to add water, we're going to add HFCS, and we need all four of the emulation components, HMI, batch, the PLC, and the model, working together to make this happen. So FactoryTalk Batch will command the PLC, telling it when to add the ingredients and how much to add of each ingredient. The PLC will then take the appropriate actions, opening the valve and monitoring the amount of ingredient that is added, and then close the valve when ingredient delivery is complete. The Mimic model, that we're using Mimic in this case, it will receive the output commands from the PLC, process them. What that means is for valves, it can send back a limit switch input to indicate if it's closed or open, but this isn't always required. For ingredients, it'll send the input to the PLC flow totalizer, so it knows how much has been added. And we'll also then modify the tank level, the LIT. So I'll get started by initiating a batch. And this is being done with Batch View client within the FactoryTalk HMI. So we'll let this load up. And to kick the batch off, we'll go to our batches. and then we will add a new batch. In this case, we are making cola. We enter the appropriate parameters for the recipe, and with what you're going to see is you're going to see these screens flash, basically requiring me to confirm that I do indeed want to take these actions. So when I'm ready, I'm going to start the batch. And for this particular system, I have to identify additional information, specifically which of the syrup tanks we're going to be using. In this case, we're going to be using syrup tank number 20. And I also have to confirm the default units. Now for this particular customer, there are some pre-checks that need to be done that they require the operator to do. So I'm going to come here and acknowledge that the system is indeed ready. After those actions occur, then the automated system will take over, and we will start by saying the water valve open, it's opening, and we'll sort of view this process again when we do the HFCS, but when we do HFCS, we will actually dig into the model, and Charles will show us a little bit of what's going on behind the scenes, how those inputs are being processed and sent back to the PLC. So you'll notice our tank level is going up, the PLC, and I do want to reiterate that this is all being driven by the PLC code. We are not using any sort of batch emulation. This is the only emulation that is going on is by the Mimic model, modeling these real world IOs. So we've now hit the appropriate amount of, or we're about to hit the appropriate amount of water. The PLC will then command the valve to shut. And after that, the batching system will then command that HFCS be added. We'll watch this valve open. We'll watch this start to rise, and then Charles will show us what is going on inside the model. So in just a moment, this valve should open. There it goes. And one other comment, this client was trying to standardize, and this is a plant packs implementation on FactoryTalk. So this valve is now open, and again, we have our tank level increasing, and now Charles will show us what's going on to cause that tank level to increase.
All right, you should see the Mimic model now. This Mimic model is primarily made up of function blocks that are connected together using just little lines. And this diagram was really designed solely based off of the PNIDs that we received from the customer. That way we could implement the proper system for our emulation. Right here, we have the tank 20 HFCS. Now this, as high fructose corn syrup is being added to the tanks, we'll see this number go up. And as this number goes up, we are going to scroll over to the right here and show that it's being added to our LIT. Now this LIT is directly being written back to the processor so that it can get a proper read for the total level. And each of these tanks is also a flow meter for each of the different ingredients. So we have here the water that would be added. And as this LIT goes up, that's the total tank level that is increased over time.
So Charles, how did you build this model? Do you care about what the code is, or what type of code, or what kind of processor is, or?
No, none of that really matters in terms of what Mimic needs. Mimic just takes everything from the PLC, including all the outputs, and then writes everything back to the inputs. That processor could be a Siemens processor, it could be a Rockwell processor. Here for Rockwell, we're using OpenOPC, which is just writing directly to those tags.
Yeah, and if I can add on to that, essentially, all you need to create this model is the PNID diagram showing, what's the flow of the system, what objects do you have in there. At that point, you can create the model, and it can actually even be created before the programming is completed.
Exactly. That's something that we tend to do, is create both the model and the program at the same time, so that once the program is done and ready to be tested out, we have a system ready for it.
Right.
So I'll go ahead and just briefly switch back to the HMI. Again, as we pointed out, we're having HFCS continue to be added here. And as I mentioned, the level will continue to go up. And again, emulation is even more, the more moving parts that you have to your system, this system has 20 different tanks, multiple ingredients. You want to be able to test all of those scenarios. And like Damien said, you don't want to have to spend resources, materials to test each of those scenarios. So again, realizing the value of emulation, not only from a time saving, but also a physical material cost standpoint. So that really is the basics. Of course, this process would be repeated for each ingredient for each tank prior to going on site, but this really gives you an idea for what we can do with emulation and sort of how we do it.
Great. Why don't you tell us a little bit of the value you guys saw as we jump back into the PowerPoint slide here? Yeah,
so as a result of running the emulation, having this virtual model, it allowed buy-in from by the client stakeholders while the system was being developed. You can get a very good idea for how the system's going to look, how it's going to operate. And as a result of this buy-in, which was especially important given the fact that they were intending to use this on multiple sites in the future. But as a result of this buy-in, the client identified additional opportunities where batch steps could be done in parallel, helping to reduce batching time, and which therefore increased efficiency. Having a realistic model also allowed operators to be trained prior to startup and without the risk of breaking something in the real world. And then because the control software was able to be debugged prior to startup, the time that was required from the time that they shut down to the time that they were able to make product again was just 7 days. And most of this time was dedicated to getting the hardware working and other activities that you really can't perform until you are shut down. I also want to mention that we have a paper based on a different project where we were replacing the controls of 12 different PLCs. The entire factory had to be down in order for us to do this, and that made downtime, minimizing downtime, super important. And not only were we replacing the controls of 12 PLCs, we were also replacing a proprietary batch system. And because of the value that emulation provides, we were able to achieve startup in only 5 days. So if you are interested in reading more of this, please reach out to us and we'd be happy to share that information with you. On the final benefit on this project was that by investing in the modeling software, the client was able to take this from site to site and they could continue the training for future operators for multiple locations. So hopefully you found the demonstration both interesting and enjoyable, and at this point I'll turn it back over to Damien.
Have you guys done emulation in something other than process? Can you do emulation in packaging as well?
Yes, absolutely. We can do packaging emulation, we can do process emulation, and you'll get the same results as far as being able to debug the code, being able to get all those advantages, anything that you can do without, that you can do prior to shutdown.
Great. So the key is kind of, as we talked about back at the beginning, it's the right tool for the right task, right? So we've been able to demonstrate where we've used a more analog approach towards the model for a process application and a more discrete event approach modeling software for packaging with Demo 3D. And I think that's the key is now that the software has progressed over the last 10 years and there's more and more tools available, it's finding the right tool for the right problem set. And we're not limited in our guys in any way into a particular product set. So we're not here pushing a product or promoting any of these particular softwares. We're promoting the process of making sure you use the right tool for the right application. If you were going to use, you're going to design a packaging application with a Delta robot and there's a Delta robot process model that you want to use, you should use that. They're going to give you the leg up in terms of that physical model, the access is already being there. And that's the right tool to solve that particular task. And that's the goal that we want to make sure people here today is that we have a variety of tools. It's really the solid approach. And that if you can get by with spreadsheet, if that level of risk is what's required for you to get through that front end engineering phase, and you don't need to, great. But if you need that extra 10%, it could be important for some people if they've got to make their numbers, right? So that may be the time you want to spend a little extra time and money, have somebody come out and do a 3D scan and put together a 3D model and help you do some modeling to deliver a better result and make sure that you can sleep better at night. So at that, I think we're pretty much close, unless either one of you have it. Philip, Charles, you got anything else?
Nope,
Okay.
I think you covered it.
So
Yeah,
at this
good.
point, I think we're going to try and open up and see if we got some questions. It looks like we have a couple. First one is, can emulation be utilized for non-batching or packaging systems? Yes. In fact, it's not as efficient and as effective for the emulation side, but the simulation is really, really, really good for semi-auto activities, right? So if you've got things that you can't automate and can't put into the model, you got some semi-auto processes that are not packaging or process related. You can look at things like assembly. We've looked at things like document management systems, right? It's just a system. We're a systems integrator. We're just looking at systems and we're using that as a tool. So you can use simulation for a lot of things that are not batching or packaging or automated focused. On the emulation side, the value is the automation. So when you're looking to emulate, you want to look at an emulation, you look at the back end of a design, you want to make sure that you're applying the exact automation that you're going to deploy in your design. And that's really the value. I hope I've answered that question. I'm going to jump to the next one. What if I have a greenfield project? How can I use simulation or emulation there? So again, if you remember, we push simulation on the front end of the engineering phase to make sure that we have the right, and we challenge each other to come up with the right options. We're evaluating everything that's commercially available and delivering the best solution for that particular task. And then the emulation is more on the back end. It's validating that design and excuse me, and giving your team the best chance of success through the startup and commissioning phase. Another question, can you enter different downtime conditions and different mean time between failures for each machine? Absolutely. So we kind of glossed through that. Charles, you want to pick up the ability to manage different stochastic processes for uptime and downtime?
Yeah, so in that demo 3D model we covered, there actually were a varied amount of mean time to reset and failure differences there. So those machines and those numbers that we gave you were actually run at a higher than normal speed. So we ran each model for about a week and got the average for a shift. So within that week time, we'll see lots of different failure reasons, lots of different reset times. And those were all collected from our line audit. And so in our OEE sheet itself, we'll have a list of every single fault and every single failure and every single reset and how long each of those took. So we took all of that information and correlated it into the model. So as the model is running, we can easily grab reports like, what was that failure and why did it take so long? Or what was the failure that was most often? And compare that to the analysis that we got from our line audit.